All right, 8.2. Here we come. You're doing great. You've been sticking to it. You've been doing the problems. You're getting better and better and better. You're learning more and more and more. Um, Man, you keep this up, and who knows? Maybe one day you'll be maybe one day you could be lucky enough to be like me and be a living suppository of information. Wow, something for us all to aspire towards. So 8.2 is our second type of confidence interval. It's also a confidence interval for the mean. However, it's used in situations where the population standard deviation sigma is unknown, which means that we have to instead look at the sample standard deviation and use that. Mathematically, it changes things. We no longer have a z interval. Instead, we have a t interval. And so that's what we'll be talking about in 8.2. Oh yeah, 2 as in a t. 2 starts with the letter t. How about that? So 3 problems I think I assigned from the syllabus. First 2 are just generic problems. Third one I believe is a kind of a word problem, involves fake Twitter followers, I believe. So again, I encourage you to pause this if you haven't already and do the problems yourself. Try them to the best of your ability. If you can't try 17, if you can't do it, then listen to me talk about 17, stop it, and then try the next one until you've tried them all. And then look at this as just comparing answers. So 17A, right? The book says a sample size of 15 has a sample mean of 2.1. And again, that's my emphasis, a sample standard deviation of 1.7. So sample standard deviation, that's the key word that tells me I'm going to need to use a t-interval. I can build these intervals with my calculator, right? I go stats because it's stats class. I go test because this would be useful on a test. And I pick t-interval because I'm using the sample standard deviation. And we'll see on the next slide how to fill in the information. Right, so that's just all the information I was provided. Sample mean of 2.1. It gives us the letter S. Look at that. Our calculator is so smart. Our calculator knows, hey, if you're using a t-interval, then you're using the sample standard deviation S instead of the population standard deviation sigma. Man, what a smart calculator. So we put the 1.7 in for that, sample size of 15. We throw in 95% for our confidence level. We hit enter, and there's our interval. So we would say that we are man, I want to say, what was it, 95%? We're 95% confident that the true but unknown mean is somewhere between 1.16 and 3.04. Yeah, there we are. So that's how we would actually say it. We're not sure what the true mean is, but we're 95% confident it's somewhere between those two numbers. It then gives us that same question, right? If the sample size were to increase, what would happen to our margin of error? This is actually, I think, our third time answering this question now. So I guess it is worth observing that, like, all the patterns we observed in 8.1, those patterns still hold in 8.2. Those are like big picture patterns that hold for actually all of the confidence intervals that we're going to talk about in this class. Sample size increases, that's more information. More information means less error, so our margin of error is going to shrink. All right, number 19. Sample size of 89 has a sample mean of 87.2. There's that keyword, sample standard deviation. That's telling me t-interval. So again, if you haven't already, pause it and fill in the numbers. Don't look at the next slide. Fill in the numbers yourself and see if you get the same interval I do. Just plug in and chugging, plug in and chugging. And there's the payoff. Again, it's not hard. It's just picking the right interval. That's the only challenging thing, right? Chapters 8 and chapters 9, I mean, there's some difficult material. Like the concepts that are going on are powerful, but they're subtle. So like really like getting it down to like the core of your being, like that's not an easy thing. But going through the motions, going through the calculations, answering questions, getting points on tests, nothing hard about that. Right. So I think I put the answer on the next slide. I think. Yep, there we are. We're 95% confident that the true but unknown mean of this generic problem is between 86.084 and 88.316. All right, so that's kind of like, that helps us kind of get the mechanics perfected. So now let's try them in the context of a word problem again. Here's Professor Broken Record. If you haven't done it already, pause it and try to do 23 on your own, and then we can compare answers. So here's the phrasing from the book. Many celebrities and public figures have Twitter accounts, surprise, with a large number of followers. However, oh my, some of these followers are in fact fake, resulting from accounts generated by spamming computers. In a sample of 46 Twitter audits. So can you imagine? Like, oh no, you get like an email or a message from I don't even know who it is, like the IRS of Twitter. It's like telling you that you're being audited. Like, oh, my Twitter account's being audited. Oh, it's terrible. The mean percentage of fake followers. So the mean percentage of fake followers was 14.1. And so this is a little tricky with a standard deviation of 9.6. So here our textbook's actually being a little bit vague, right? Because what type of interval should we do? It says it wants a 90% confidence interval. And so your question is that a Z interval or is that a T interval? And technically that boils down to, well, am I using the population standard deviation, sigma, or am I using the sample standard deviation, S? And it's kind of hard to tell, right? Because our book just says standard deviation. In my opinion, it's a little bit of a flaw in our book. In my opinion, it should be a little bit more explicit. On a test, I promise you I'll be very explicit. I'll say population standard deviation or sample standard deviation. However, for our textbook, when they just say standard deviation, they mean sample standard deviation. That's true for all future problems. Excuse me, it's also true for your quizzes. So when they say standard deviation with nothing in front of it, with no elaboration, they're implying sample standard deviation, which tells us to use a T interval. So we just fill in the blanks. 14.1, 9.6, 46. We were told a 90% confidence, so 0.90. Move the cursor over calculate, hit enter. And so there it is, right? So, right, some accounts have a higher percentage of fake followers than others. What's the average amount, the average percent of fake accounts over, say, all celebrities? Well, we're 90% confident that the average amount of fake accounts is somewhere between that 11.7 and 16.5%. Yeah, which is what I say right here. So if somebody told you, like, I actually think that this whole fake Twitter account thing, it's all fake news. It's not really as out of control as people have been trying to like make us believe, right? All these fear mongers out there. I actually think it's really just 10%. I think only 10% of all Twitter accounts are fake. Do we believe that claim or not? Well, I would say we shouldn't believe that claim, right? Because based off our data, based off our sample, based off our Twitter audit, right? We're 90% confident that the true percent of fake accounts is somewhere between 11.7% and 16.5%. And notice 10% is not within that interval. So again, we don't know what it is, but we've narrowed it down. We've narrowed it down to being between 11.7 and 16.5, and hence we do not believe that 10% is a plausible value for the average percent of fake Twitter accounts. And that's that, right? We're really starting to kind of fly through these things. So take a little bit of a break. We often do something fun. We literally stop and smell the roses at Longwood Gardens. I don't know, maybe for this break we could go out and we could I don't know, maybe we could do something a little more altruistic, maybe something a little bit more charitable. Maybe we could I don't know, maybe we could call our parents and tell them how much we love them. Oh, I'm sure they would love to hear that. Um, if we're a little bit older, maybe we could call our children and tell them how much we love them. Yeah, they may not want to hear that, depending on how old they are. I don't know. Maybe we can go to the local Red Cross and donate blood. That'd be kind of cool. Particularly if you're type O. If you're type O, then yeah, there's someone out there somewhere who needs your blood. So why don't you go ahead and consider giving some blood? And I think a lot of times after you give blood, they'll give you a couple cookies. So that's pretty cool. All right, so enjoy your cookies, and I'll see you afterwards.